Hi everyone, I thought I'd just take the opportunity of running through a quick power analysis for you, just the basic rundown of how this works. So the thing I'm taking it from is your e-text example page 355, okay? And all they've given us here is not very much, it's just given us some output. And so obviously the experiment's been run because we have output and data, so what we're looking to see here is if this study had sufficient power. As you can see here, it's an insignificant effect, so we need to do a power analysis. So, what are the steps that we go through here? First of all, we need to work out which table we need. We are calculating power for a given effect size. We aren't trying to work out how big a sample is because we've already run the experiment, so we're trying to work out power itself for a given effect size and degrees of freedom. We have here, it might be a factorial ANOVA, I'm not really sure, to be honest, it didn't say. We have an ANOVA. Okay, now what we're going to need is Appendix C3, okay? That's where these tables are located for this particular problem. We need to find the correct degrees of freedom to determine the correct table because there's a different degrees of freedom for each table, okay? So how do we know which table? We come over here and have a look at the between groups degrees of freedom. That's the one that matters, and we have a degrees of freedom here of 2. So that means that we need table C3.2, and the reason why we know that that's the correct table is because it says here DFA2. Okay. Next thing we need to know is what effect size we're looking at and what is the degrees of freedom of the residual. If we come back here, we can see that degrees of freedom is rather conveniently 177, okay, which is not always the case, it's not always that convenient. So we come down here at 177. Now, which effect size should we use here? It really depends on the type of ANOVA you are running. We haven't just been disclosed that in this example. For some ANOVA we'd use 0.14, for others 0.06. So you need to go and check your notes about which effect size we're looking at here. My kids are currently yelling at me. Okay, so there's two that we particularly use, and that's one is 0.14 and one is 0.06. And if we come down here, we have power of greater than 0.995 and power of 0.86. So what does that mean? We had a greater than 0.995 chance of detecting an effect size of 0.14. My kids won't go to bed because it's daylight savings. We also had an 86% chance of detecting a much smaller effect size of 0.06, which we describe as medium. So no matter what kind of ANOVA we've been using in this study, the study was sufficiently powerful. In an exam, we'd expect you to know whether or not you need a 0.14 or 0.06, and you will have the information you need to make that call. You know, in your report where you do that line that says something like a factorial analysis of variance was performed, or a within subjects analysis of variance was performed. That's your clue to tell you which effect size you need. She really won't go to bed, so I'm going to wrap this up. I will post these particular slides as well so you can have a look at it at your leisure without anybody yelling at you in the background. I've also given you the e-text version of this example. This is all on page 355 of your e-text. Just note that here it's referring to the wrong table. Okay, that should be C3.2. I hope that's useful to you. I'm really sorry about the yelling in the background, but this is daylight savings and I'm a parent. Good luck with your exam, and please do shout out if you have any other questions.